Hi, welcome back. We're still talking about factoring the greatest common factor of a polynomial. And if you remember in the last video, when we factored out the greatest common factor, it actually turned out that the greatest common factor was a monomial. But not all polynomials have a monomial GCF. Sometimes the GCF is another polynomial, either a binomial or a trinomial. And that's what I want to look at today. Okay, so let's consider the polynomial written kind of like this. It's a little bit strange, but actually let me erase that because that just got in the way. We have the quantity a minus b times x plus 5 plus the quantity a minus b times x minus y. Now, you'll notice that there are technically two terms here. Okay, two terms here that are separated by an addition sign. And each of those terms is already broken up into factors. So the first term has one factor, two factors, and the second term has one factor, two factors. So if we look closely, we'll notice that each of those terms has a common factor, right? The common factor that they both have is a minus b. So a minus b is the GCF in this case, all right? And so when we factor out a minus b, remember, we factor out a minus b, what we're doing is technically dividing each term by a minus b to get our leftovers, right? So we factor out a minus b from each of those terms. What's left over from the first term is x plus 5, and what's left over from the second term is x minus y. And so when all is said and done, we have our GCF of a minus b, and we can combine our leftovers together to form another polynomial, 2x minus y plus 5. Now, this polynomial was already, the one that we started with, was already kind of written in a partially factored form, right? Each of the terms was actually already written in factored form, but that's not always going to be the case, all right? So let's consider this polynomial x cubed plus 3x squared plus 4x plus 12. Notice we have four terms of this polynomial. And when we start factoring a four-term polynomial, the first thing we're going to look at is we're going to see if all four terms have a GCF. Okay, so we're going to see if all four terms have a common monomial GCF. And if we look closely, we realize that they do not, right? There's no coefficient part of the GCF of all four, and there's no variable even in that last term, so there's no variable part of the GCF. So the next thing we're going to do with a four-term polynomials is we are going to do what's called 2 by 2 grouping. Okay, so we are going to separate those four terms into two groups of two polynomials, and we're going to find the GCF for each group, okay? So here's my first group, x cubed plus 3x squared. The GCF for that group is x squared, and if I factor in x squared from each term, I get x squared times x minus 3. Then I look at the second group of two and I find the GCF and I realize, hey, the GCF is 4. I factor out of 4 and what's left is 4 times x plus 3. Now, just to compare it to what we had up above, we have the two terms. Each term is broken into two factors. You'll notice that they have a common factor. The common factor of both of those terms is x plus 3. So the GCF is actually x plus 3. When I write it in its factored form, the GCF is the first thing I'm going to write. And then the leftovers, or if you think about it, it's the factors that are not part of the GCF, that's what comes next. So we have from the first term, it's x squared, and from the second one, it's plus 4. And so when we factor a four-term polynomial, we're going to try 2 by 2 grouping after we see if there's a monomial GCF from all the four terms. And then we're going to pull the GCF from each of those groups of two and combine them as one factor, the GCF factor. And then the leftover factor is going to come in the other set of parentheses. That's called 2 by 2 grouping, okay? One thing to remember is that at times we may need to reverse a subtraction in order to get a common factor. So, for example, if we factored the GCF from 2 by 2 grouping and it turns out that the leftovers in each of them are opposites of one another. So in other words, if we had like A minus B and B minus A, okay? So if we had A minus B and B minus A, these are opposites of one another, but these are not considered a common factor yet. We can turn one of those into the other one if we factor out an additional -1, okay? So we can make A minus B equal to B minus A if we factor out a -1. So A minus B is actually equivalent to the -1 of B minus A. So we're factoring out a -1, and then we can turn them into each other. Let's see how that actually looks in play, okay? So let's consider this polynomial ax minus bx plus by minus ay. There's no common factor for all 4 terms. So we're going to jump in and we're going to try 2 by 2 grouping. Let's group them into 2s, okay? From the first set, you'll notice that I have a common factor of x. And what's left over when I factor an x out is a minus b. If I look at the second set, you'll notice the common factor is y. So plus y. And the leftovers are b minus a. Now, we don't have any common factors now. Look at this. A minus b and b minus a are not the same thing. But if we factor an additional -1 from b minus a, right, then this becomes x times a minus b plus y times -1 times, now it's factoring out a -1 makes b minus a into a minus b. Aha. You'll notice we can combine the y and the -1 together as -y or minus y times a minus b. And now the polynomial has common factors, right? So the common factor is a minus b. So that is our GCF, a minus b. And the leftovers would be the things that are not in parentheses. That would be x minus y. So again, this is just showing you that when you factor 2 by 2 grouping, if it turns out that the common factor doesn't exist, but they are kind of in opposite form of one another, you can factor out an additional -1 from one of the factors, and then it'll become its opposite. Okay? So I want to take you back to the very, very, very beginning here. Remember, earlier on, let me just scroll up here. Earlier on, we talked about something called the zero product property, okay, which said that if you have two things that are multiplied together, like A times B, and you know that the product is equal to 0, then A is equal to 0 and or B is equal to 0. We can use this idea. Notice this is factored form, right? A times B, 2 factors. If we know that those factors are equal to 0, then we can set them each equal to 0 and figure out what the zeros of our polynomial is. Let me head back here. I'm just going to scroll for a second here. So let's go back to the very beginning of this section, okay? We have the equation x squared equals 6x. Now, I showed you how to solve this graphically, and you'll notice that the picture just off to the right here shows you how to, what it looks like if you set it equal to 0. But we now have the ability to take the expression or the polynomial x squared minus 6x and factor the GCF out, right? We can turn it into its factored form. The greatest common factor is x, and what's left over is x times x minus 6. And if we know that A times B is equal to 0, then either x is equal to 0 or the x minus 6 is equal to 0. So essentially what we've done is we have set each of the factors, after we factor it, equal to 0, and we can solve it for x. And that'll give us our zeros, right? So in this picture, we have x equals 0, x equals 6. You'll notice that using the zero product property, we can just confirm what we see graphically, where x is equal to 0 and x is equal to 6. So do the zeros match the solutions? Yes. This is just an algebraic way to find the zeros, just like you did graphically. That concludes our lesson on factoring the greatest common factor and using the zero product property. Let's see, what else did we learn? Oh, and solving graphically, right. We'll start something new next time. I hope you enjoyed this video. If you have any questions, please contact me before you get started or while you're working, and I can answer your questions.